Welcome to Module 3, Section 6 of your California Contractor License Exam Prep Course. In this lesson, we'll discuss roof pitch, slopes, and diagonal measurements, three essential concepts you'll use regularly as a B2 residential remodeling contractor. Understanding these concepts is key for calculating materials, ensuring proper water drainage, meeting code requirements, and accurately cutting components during construction. Mistakes in these areas can lead to leaks, structural issues, failed inspections, and costly rework. Mastering them now will help you both in the field and on the CSLB exam. Let's start with roof pitch, which describes the steepness or angle of a roof. Roof pitch is typically expressed as a ratio of the vertical rise to the horizontal run. In U.S. construction, it's usually given in inches of rise for 12 inches of run. For example, a roof with a 6/12 pitch rises 6 inches vertically for every 12 inches horizontally. The higher the first number, the steeper the roof. Roof pitch matters for several reasons. It affects the type and amount of roofing material needed, determines how quickly water and snow shed from the roof, and impacts safety when working on the surface. To calculate roof pitch, you measure the vertical rise of the roof over a 12-inch horizontal span. If you know the rise and run of a roof section, you can express the pitch as a fraction or ratio. For example, a roof that rises 4 inches for every 12 inches of run has a 4/12 pitch. Roofing materials like shingles and flashing are often rated for minimum slope, and building codes require certain pitches for proper water drainage. Flat roofs, with pitches of 2/12 or less, need special materials to prevent water pooling, while steep slope roofs shed water faster and may require additional safety measures during construction. Now let's talk about slope in a broader sense. Slope applies to any surface, not just roofs. It describes the incline or decline of the surface relative to a level horizontal plane. Slope can be expressed in three ways: as a ratio, rise/run, as a percentage, rise divided by run times 100, or as an angle in degrees, using trigonometry. For example, a driveway that rises 1 foot over a 20-foot horizontal length has a slope of 1/20th or 5%. Proper slope is important for water drainage around buildings, accessibility ramps, walkways, and landscaping features. Code requirements specify minimum and maximum slopes for different applications, such as a 1/4 inch per foot slope for proper drainage on patios or a maximum slope of 1/12 for ADA-compliant wheelchair ramps. Diagonal measurements are another essential skill in remodeling. They are commonly used to ensure structures are square, to calculate lengths for angled cuts, and to verify dimensions when working with triangular or non-rectangular layouts. The Pythagorean theorem is the foundation for diagonal measurements in construction. This principle states that in a right triangle, the square of the hypotenuse, the diagonal side, equals the sum of the squares of the other two sides. A superscript 2 plus B superscript 2 equals C superscript 2. For example, if you have a rectangular floor layout measuring 6 feet by 8 feet, the diagonal is square root 6 superscript 2 plus 8 superscript 2 equals square root 36 plus 64 equals square root 100 equals 10 feet. This calculation is used to verify that a layout is square. If the measured diagonal matches the calculated value, the corners form a 90-degree angle. Diagonal calculations are also used when cutting rafters, stair stringers, or other angled components. Knowing the pitch or slope of a surface allows you to calculate the diagonal length needed for framing members. For a roof with a 6/12 pitch, the run is 12 inches for every 6 inches of rise. The rafter length diagonal for 1 foot of run is square root 12 superscript 2 plus 6 superscript 2 equals square root 144 plus 36 equals square root 180 is almost equal to 13.42 inches. Multiply this by the total horizontal span to get the full rafter length, adjusting for overhangs and bird's mouth cuts. These calculations ensure accuracy when framing roofs, stairs, or angled walls. Small errors in diagonal measurements can throw a project out of square, causing gaps, misaligned finishes, or structural weaknesses. Understanding how to calculate diagonals also helps you estimate material needs more precisely, as angled cuts often require slightly longer pieces of lumber or more material than straight cuts. As a contractor, mastering roof pitch, slopes, and diagonals improves not only the quality of your builds, but also the accuracy of your estimates. You can quickly determine the amount of roofing material needed by calculating the roof surface area based on its pitch. You can verify that drainage slopes meet code before pouring concrete. You can ensure that rooms are perfectly square before installing cabinetry or flooring. These skills save time, reduce waste, and increase client satisfaction. On the CSLB 2 exam, you can expect questions asking you to calculate roof pitch ratios, determine slopes for drainage or accessibility, and solve for diagonal links using the Pythagorean theorem. Practicing these calculations now will help you answer those questions confidently and apply the knowledge effectively on the job site. In summary, understanding roof pitch, slopes, and diagonal measurements is essential for residential remodeling contractors. These skills ensure proper water drainage, compliance with codes, accurate framing, square layouts, and precise material estimates. They also play a direct role in passing the CSLB exam, as math problems in these areas are common. By mastering these concepts, you'll be better prepared to manage projects efficiently, safely, and profitably.